Welcome back, everybody. We are still on section 5.1. We're on the next page, the elimination method. A few reminders about the elimination method. You need to make sure that all variables line up. So what I mean by that is if we had 3x plus 4y equals 7 and 2y minus 4 is equal to 9x, these aren't lining up. My x's need to line up with x, the y's need to line up with y's, and then the numbers without variables need to line up together. And so we would need to pick one of these two equations to switch around. I would probably pick the bottom equation, subtract the 9x over, keep that 2y, and then add the 4 over to the other side of the equal sign to make it look like that. So that's the first reminder. The second reminder is that it does not matter which variable you choose to solve for first. Remember, you can multiply. We really don't use division. Multiply any equation by a number. You can multiply one equation, the other equation, or both. So those are a few of the reminders. Let's go ahead and give it a shot. Over here on my left example, the x's line up, the y's line up, the equal signs line up, so we're good. I cannot just add these and have something add to 0, and that's the point of elimination method. I'm adding something together so that it equals 0. So we get to decide, do you want to get rid of the x's or the y's? I think I'm going to get rid of x. I want x to be the exact same coefficient or number in front and have 1 be a positive and 1 be a negative. So I'm going to multiply this top equation by 2 and the bottom equation by -3. I could have multiplied the top one by -2 and the bottom by +3. Again, that doesn't matter. When I do that, on the top I get 6x minus 8y is equal to 2. Negative 6x minus 9y is negative 36. Now, when I add these two equations together, I have 6x plus negative 6x, which adds to 0 and eliminates out. Negative 8y plus negative 9y is negative 17y. And 2 plus negative 36 is negative 34. Divide each of those by negative 17, and we get y is equal to +2. So the first part of our ordered pair is +2 for y. Still have to solve for x. I gotta go back into these equations. I'm gonna go back into my original 2 and decide, do I want to solve the top equation or the bottom equation for x? And again, it doesn't matter. I'll pick the top equation and plug that 2 in for y. So 3x minus 4 times 2 is equal to 1. 4 times 2 is 8. Oops, add 8. 3x is equal to 9. Divide by 3, and x is equal to 3. So the solution to our system, the place where these two lines would cross, if I graph them, is 3, 2. Let's take a look at this second example. This time I think I'm going to get rid of y. My x's line up, my y's line up, my equal signs line up, so that's all good. I can't add these together and have either x or y eliminate out by adding to 0. So I'm going to multiply the top equation by 2 and the bottom equation by 3. Doing this would allow me to get a positive 6y on the top, and because on the bottom that's already a minus 2y, 3 times negative 2 is negative 6. So I'll end up with 4x plus 6y equals negative 2. 9x minus 6y is equal to 54. Now I can add these together. 4x plus 9x is 13x. 6y plus negative 6y adds to 0 and eliminates out. Negative 2 plus 54 is 52. Divide both sides by 13, and we get x is equal to 4. So the first part of our ordered pair answer is x is 4. From there, I'm going to go ahead and plug that in to one of my original equations to solve for y. Let's put it in the bottom equation this time. 3 times 4 minus 2y is 18. That's 12. Subtract the 12 over. Divide by negative 2 on both sides. And we get y is equal to negative 3. So 4, negative 3 is our final answer. That's it for today. Before you leave our classroom for today, make sure you stop over and take that day 2 exit ticket and let us know how you're doing. If you like and subscribe, that would be amazing. Just kidding. Hope y'all are doing well. Talk to you soon. Bye.